What up, Calc fam? As you can see here on the board, what up, Calc fam? It's your boy Alec and your boy Alex Witt on the film right now. Today we're here to talk about differentiability and continuity and how they're both alike and different. Today we're going to give you definitions of differentiability and continuity. We're going to give you examples of functions that are differentiable and also continuous, and we're going to show you relationships between the two. We'll also even show you a graph if you're more of a visual learner, you know. But we in here, huh? Alright, continuity, bam, let's go. Continuous, continue. Yeah, we're going to continue this video. Alright, so you got the VLT. It could be continuous, but that's not really what we're talking about here in Sister Dennis's calc. AB. Alright, so definition, continuous if it's continuous at every point in its domain. You may be wondering what the domain is. You might find it on like GoDaddy.com or Google, but it's really the set of x's. Bam! Right here. So you got y equals x, our favorite kind of graph, the easiest one, slope of 1. Alright, bam! Did you see that? Did the marker leave the board? I don't think so. Bam! That looks pretty continuous to me. So let's say, if the marker doesn't leave the board, it's continuous. There you go. It's Alec, guys, and I'm back here, and now we're going to talk about differentiability. Yeah. Alright, enough of that. Now we are going to get to differentiability, not the definition that 2 Chainz has given us. Okay, so differentiation is the process of finding the derivative. When we say that, we mean we are finding what y prime is, or f of x, or f prime of x is, of a certain function. So here's an example here. We have our easy function, y equals x again, which Alex loves, you know, along with Alec, myself. So here we have the line, y equals x, where the domain equals the range. So if you take the derivative of y equals x, you get y prime equals 1. So as we have said here, function is differentiable at x if its derivative exists at x. So here, once we found the derivative of y equals x, we drew the line at y equals 1, and it intersects at a point at y equals x right here, which means that that point on this graph is differentiable. Relationships, every teenager's favorite topic in the world. We're going to start out with 2 relationships here in this class. Sister Dennis loves her first period AB Calc class. Yeah! Alright, second one. Ben Sutman loves eating in class. Put that food away, Ben. Alright, now, the real relationship we're talking about here is differentiability and continuity. Differentiability implies continuity, so if a function is differentiable, it's continuous. We're going to put a little harder on that one, just because it's a nice relationship. Alright, our second point. Continuity does not always mean differentiable. So it's kind of like a bad relationship. I'm sure we've had many. So it starts out with a nice little love, and then gone. Alright, so we don't like those relationships. Now you might be wondering, when does that happen in a function? F of x equals the absolute value of x minus 2. Bam, there it is. It's continuous. Whoop. Didn't lift my pen. But there is no tangent line here. It is not differentiable. See you later. Okay guys, now we have the conclusion. Wait, conclusion? This is the last time we're ever going to be in class together, guys. It's all good though, my boy 2 Chainz will always cheer me up. Okay. Today, in review, we talked about the definitions. We gave you some examples, and even some pictures for those visual learners out there. And we discussed the relationship between both differentiability and continuity. That's all we have time for, guys, and in the words of our father, 2 Chainz, we're different.